Yes. So let's get started with today's session. Let me share the screen. A quick confirmation if you all can see the screen. Okay, great. So let's get going now. Today's our topic is about PyCaret, and today we will be seeing binary classification using PyCaret. Now, the things that are going to be covered today and our agenda is how the PyCaret is low code. We will see, how it is a low code package. That is the first thing. And then we will also see how the data pre-processing is automated. Okay, so pre-processing is automated, and also we will see machine learning algorithm pipelines. These are the things that are going to be covered today. Now, let's understand what is PyCaret. PyCaret is an open source, low code machine learning library in Python that automates. Okay, so it is low code. That's great. The second thing is it's going to automate machine learning workflow. The entire workflow, what we learned as part of our data science and machine learning, is automated in this single package. Okay, so what are the things that we have seen? We get the data, right? After we get the data, we perform the pre-processing. After pre-processing data, we get into partitioning. We partition the data, right? And after partitioning, so what is there in this partition? We've learned about three different things: training the data, testing the model, sorry, and we also have seen validation data. All these things. Once we split or partition our data, then we go to the next part. We start building different models. And from these models, we evaluate and pick the best one, whichever is giving us the best accuracy when it comes to classification models. Right. Then, is the process finished here? No, we still have to deploy our model. Okay, so these are the things that are there in our ML. So it is automating all that workflow in PyCaret. That is the speciality of PyCaret package, right? It is an end-to-end machine learning and model management tool that speeds up the experiment cycle. Now, as part of our, our data science, we are doing a lot of experiments. What are the experiments that we try? All the different models, fine tuning, you do the hyperparameter tuning, you try to build different models, hyperparameter tuning, or you try different models from classification. All these things are experimental. You cannot reach to the result directly. You need to do a lot of experiments, lots of changes in your model to get to your final result. So this PyCaret is speeding up that process. What they have done, they have given everything in a single package. Okay. And the speed is exponential and makes us more productive. So that is what is all about PyCaret. Now let's see, okay, we understood the PyCaret. It looks all fancy and easy. Now let's see how to install the PyCaret. Now to install, we have few steps. These are the common steps that we follow for any or other package. Now I have already done the installation. I just want to show you, okay, the steps. Now, why I did that well in advance is it's going to take at least half an hour, and today's our session is half an hour, but I'll walk you through all the steps and show you how the results will be. Okay, now go to the command prompt, and your first thing is you're going to create a conda, and you're going to create the environment at the prompt. For that you are using conda create hyphen double hyphen, right? Name, this is the part, command part, and your environment name, whatever name you want to give to your environment, you can just give that. And you should give the Python version. Which Python version? Okay, Python is equal to 3.8. Okay, let me show you that. When I run that, here is the thing for you, conda create, and I have given my environment name as PyCaret. Okay, and Python 3.8, the environment is created. Okay, this is the first thing which is done. After creating the environment, okay, that was first thing. Next, we are going to activate the conda environment. For that, the syntax we have to follow is conda activate whatever package, the environment name you gave. Okay, so I'll show you that as well. Here I have given all this, and then it will ask, do you want to proceed and all. After that, the conda environment is created. See, it's going to take a long time if I keep running all this. So I have just done it before class. Okay, so this is going to take some time when you start installing the PyCaret. It will take some time. Okay, once this is created, once your environment is created, you will have to activate the environment. So this is the function that you have given, conda activate PyCaret, because PyCaret is the name which I have given. Now from there, you will have to install PyCaret. How to install PyCaret? Simple, pip install PyCaret. Now, once this is created, okay, once this is installed, what you do is you are going to create a kernel in that environment, in our conda environment. Okay, so we are going to say Python -m ipy kernel install double hyphen user double hyphen name. Here you will give PyCaret because that is the name which I have given. Whatever name you're giving, you will have to replace that. Double hyphen display, double hyphen name, and in quotation, whatever display name that you want for the kernel. Okay, so yeah, you do that and your kernel will be created. Okay, once the kernel is created, you go to Jupyter Notebook, or you can also go to Google Colab. Okay, this is the installation part. Once the entire installation is done, or you have followed all the 4 steps, you can go to the Jupyter Notebook. You can open the Jupyter Notebook, and then I have stored my file, the code file, which I will be sharing with you in pycaret.ipynb. Okay, once when I click that, my code is ready. Okay. Now these are all the things that are there, which I'm going to share with you about PyCaret, how to do the installation. All the commands are given here. Okay, so if you're going to use Google Colab, now I have opened my Jupyter notebook, but if you want to use it in Google Colab, there is extra 2 lines which you will have to run. Okay, that will enable your Google Colab. With PyCaret, you want to use Google Collaborate, so you are creating that. And now let's get into the details of what is done. Okay, now before I show you this, I'll show you all the step-by-step process what we are going to see there. We are going to see the binary classification, and binary classification
I'm
is...
sorry to interrupt you.
Yes.
Actually, I'm not getting what is this PyCaret end-to-end. Miss, you are talking about the workflow of machine learning. That means, is it a kind of auto ML or something else?
Yes, we can't say that. It is a library, right? So do one thing. Just wait until I show you the code. You will understand clearly
Okay,
what
ma'am.
I'm trying to say. I understood your question, but for your question, the answer is in the code part.
Actually, ma'am, sorry to say, actually, I'm not getting why we are using this PyCaret. You have said no. Okay,
you understood. See, what you understood till now, you got one picture.
Yeah.
But end to end, all the process that, you know, data pre-processing, modeling, evaluating, predicting. You know about pipelines? Do you know about pipeline?
Yeah, ma'am.
So you are kind of creating a pipeline.
Okay, ma'am.
Okay. So just hang on. After I finish the code, again, you can ask the questions.
Sure, ma'am.
I feel for your question, the answer is there in the code part. Just
okay,
hang on.
Okay, ma'am.
So now, yeah, we were talking about what is binary classification. Binary classification, we have 2 classes, either yes or no, pass, fail, or positive or negative, such things. Okay, so we are using PyCaret to do the binary classification. Now the question will be, can I use for multi-class? Yes, you can. And you can also use for regression. Today, we are going to cover binary classification. Okay. Now, see, I don't remember. I didn't get your name. I'm sorry. Here, it is having 18 algorithms in this package. Now, till now, what we have seen packages which were having models, right? Classification models or regression models like that. Here, it is a combination of 18 algorithms and 14 plots. Okay, and along with algorithms, it also has hyperparameter tuning, ensemble technique, advanced techniques for stacking. All these things are there in a single package. I hope you're getting the idea, little better, clear picture now.
Yes, ma'am. Now it's clear.
Yeah. So just with a few lines of code. Now, what we did, you may say, oh, we have sklearn where we have all the algorithms. But there the number of lines are more. Here the number of lines are very less. Okay, you will see that in the code. Again, it is saying end-to-end ML is covered. Next, see the code part. If you come to PyCaret, okay, so you're setting up. You're just using one function, setup. It will do the entire pre-processing. In sklearn, if you take, for each pre-processing step, you have a separate function. But coming to PyCaret, all that is done in a single function. Okay, now I think you got even better picture. So that's why I said just hang on, you will follow. Next, this compare models, it will compare all the different models. Okay, it will build, what it does is, it will build all the models possible on that data. And it is comparing the models and giving us which model is giving me which accuracy, which is giving the best precision. So it is going to compare all at one single function. So that is where the advantage of PyCaret is. Create model. Okay, if you don't want to build all the models, you can create your own model. Give whatever model you want to build. Okay, after building the model, you can tune the model. Meaning hyperparameter tuning. Just one single command. That's it. Okay. Plot, when you say plot model, there are 14 different models, right? Those models you can start plotting or graphing them. And you can predict the model. You can finalize the model. You have built multiple models, right? Whichever you want to select, you have to give that as final model. So the PyCaret will save it. And then depending upon this final model, you can predict or validate for the next data, the unseen data, you can do the prediction. After all this is done, okay, after all the steps are followed, you have your final model, right? And then what you do is you just save the model. Now, when you save the model, we have seen pickle and job-lib in our data science classes. So like that, it is going to save the entire pipeline. All the steps, data pre-processing, all the models, the final model which you have stored. Okay, the final model is saved here. All the steps are also there. Data pre-processing, the final model, the what it has to predict, all the steps are saved. Now, once it is saved, whenever there is a new data, you can load this saved model, right? And then you can do the predictions. You can do predictions for new data. And you can deploy the model as well. These are all the functions that are there in PyCaret. Okay. Now, yeah, when I explain like this, some people are able to picture it, some people have doubt. So what we do a hands-on with some example, right? This code, whatever I'm sending, you can use both in Jupyter and Google Colab. I will share it. Okay. Now going back, let's get back to our Jupyter. Here, this is the data set. Okay. In the data set, let's see what is the data set about. This is about, the default, the credit card clients are there, whether they're default or not. So default is our output variable. And ID is given, limit balance, how much balance is there, the gender of the client, whether they are educated, what is the education background, whether they're married or not, right? Married, single, others. 3 categories are there. In education, see, graduate school or university, high school, others, unknown, like that, 6 categories are there. Gender is in 2 categories. Age will be numeric. Then payment, how many months they are going to pay. Then bill amount, what is the amount, bill statement. Then how much they are going to pay. All these details are entered, and finally we have our output variable default, whether they will default or not default. Okay, so binary classification we are going to do. We understood the data set. Next, we are going to load the data set. See, all you have to do is just from PyCaret, this is the inbuilt data set. Okay, import get data function, and you are using the get data function with credit data. This is already there. So all that you do is just run it, and you can see that the data is loaded, right? Next is, let's check the shape of the data. It has 24,000 records and 24 columns or features. Next, we are going to split the data. Dataset dot sample, and you are telling frac is equal to 0.95. So what you are doing, from your entire 100%, you are taking out 0.05 as validation. Okay, you're taking this as validation. Final test which we do, right? Validation. But in this 0.95, again, there will be train and test. Okay, we are doing this kind of splitting. And random state, you're storing it. Random seed. Set seed is there, right? You're going to set that as, you can give any value here. And next is you are dropping the index for the unseen data. The unseen data which I'm talking is that 0.05, whatever the 5% of the data is there, right? That will go into the unseen data. Now, if you see here, we are asking to print the data as well as the unseen data. Now, the data which we are using for model is 22,800, that is 95%, and 1200 records went into our unseen data so that we can do validation at the later stage. Okay, next we are going to set up. When I said setup function is used for data pre-processing. Okay, so let's see how to do that. You are going to PyCaret dot classification import star. That means the entire functions which are available in the classification. And next you are going to set up passing the data. Target is default and session ID. You can give, this is like again random seed, right? You can give any number here. Now, if you look at the output, okay, it is giving me the session ID and target is default, target type is binary. If you see, it is setting up the data. Label encoding is not done. Original data is this much. Missing values, there are no missing values. How many numeric features are there? 14 columns are numeric, 9 are categorical. Okay, so it is doing all the pre-processing that we do as humans. Everything it is checking, right? See here, it is showing what is the train data set, what is the test data set, and then whether the shuffling is done for train test. Yes, like that, it is giving me all the k-fold is used. How many times? 10 times. Okay, because our default will be a imbalanced data set. So it is using internally. We did not mention anything. Automated. The entire process is automated. So it itself decided that it is an imbalanced data set. So it has to go for k-fold cross validation, right? Then a CPU jobs, whether it is parallel processing, right? All these things it has done. If you see imputation, simple imputation, it has done. Okay, so all this, it has done normalization, transformation. Whether PCA was done, no transformation required, no PCA required. If it was required, it would have done it internally. I hope now you are getting the clear picture why I said automated. See, with single function, all the data pre-processing steps are performed on the data. Now it is ready. Okay. Now that data is ready, what are we doing? We are just comparing the models. That means whatever models are possible, it is binary classification. So whatever classification models which handle binary classification are built. Okay, like this. Ridge is done, ridge classifier is done, linear discriminant analysis, gradient boost, ADA boost, light gradient, random forest, extra tree classifier, logistic regression, dummy classifier, KNN, SVM, decision tree, quadratic discriminant analysis, naive Bayes, all the models are built. Okay, and here because you did not give any argument, it has built all the models. If you give like top 3, it will give only top 3 models. That is first thing. The other thing, see here, for every model, it has given accuracy, AUC, recall, precision, F1, kappa value, MCC, and all that. Okay, and what is the time taken for each model, it is explaining. Now the yellow things which are highlighted, accuracy is really good when it is ridge classifier, and precision. Okay, now gradient boost is giving the area under curve the best one. Like that, it has highlighted what are giving. Linear discriminant analysis is giving me the best F1 score. That is the balance between recall and precision is very good when it is in this model. Okay, and naive Bayes, what is naive Bayes giving us? Best recall value. Okay, so it is comparing and giving all the values. From this, you can finalize a model. Okay, Best model, if you are asking for best model, it is saying rich classifier with these parameters is giving the best output. It is also giving us the best parameters. Okay. So
Ma'am,
this
should
is
we select the best
yes.
model as per the F1 score or something else here? Actually,
Here it is not taking F1, it has taken accuracy. See, it is
okay.
giving rich classifier, right?
Oh, regression sort of.
Huh. So if you want to change it to anything else, you can change it. Now what
Okay.
you do, you want to create your own model. This model you did not create. When you say compare models, all the models output has been given automatically. But you are telling that, okay, I don't want to compare all the models. I want to build my own model. I know for classification, random forest is good. So let me build one model. Okay, you can do that also. Here, if you ask models is one function. It will give all the possible models. These are all the models. From this, you can select which model you want to build. Okay, here it is not giving the output, guys. When you say compare, that is when it has built the model and given the output. But if you just say models, it is just giving the model names. Okay, so now what you do is you say create model DT. Here it has given, see, DT is nothing but decision tree. You have to use this ID only. Now when you give DT, it is giving me the accuracy AIC score for decision tree, mean value, standard deviation, all this information. Now when you say print DT, what it will do, it will give you the arguments which has given the best result. Okay. Next, you are creating another model KNN. You can create separate models like this KNN. Here, random forest. Okay, you have built all the independent models. Okay, now can I tune a model? Okay, you can tune the model. What is the function? Tune underscore model. Hyperparameter tuning is done of decision tree model which you have already built. Now you are able to do the tuning part. And again, when you say print tune DT, it is giving me all the parameters. If you want to check, you can check. See why I'm going like, you know, these are all the parameters, the best optimizers, because when we were doing in the class, we have seen all these, right? When you give it in the grid search, it will take the optimum value wherever we are getting the best accuracy. Those arguments it will take and it will store in the grid, right? That part it is showing us as display, as the output. Okay, I'm sure you all have all the knowledge of these things because you all have finished the course. Now, what you're doing here is in grid search, along with the grid search, you can also give the range that you want manually. So here you are trying to give that. This is one way, right? Default one, tune model DT. It will tune automatically internally. But if you want to pass any argument, it is open for that as well. Here we are taking the KNN model and passing the range of neighbors from 0 to 50. So it will build all the 50 different models and give us the accuracy. Okay. Wherever we are getting the best accuracy, that model will be stored. Okay. Now we are doing fine tune on the hyperparameter tuning on RF. RF means random forest. This was KNN. The one which we built earlier was decision tree. So we built all the models. Okay. This is very easy compared to all our other packages. Here things look very simple because everything is automated, right? Next, you can build the plots for the models. How to do that? You just have to say, because you already built the models, right? The models are already stored. Tune underscore RF. This is the last model which we have built here. It is remembering the name. When you say tune model RF and you are storing in tune underscore RF, it is stored. So you are just using that tune underscore RF model and plotting the model and giving the argument as AUC. So it will give us the AUC plot. Area under the curve for tuned RF. You can see that it is 0.74. Okay. Similarly, you can build any other model. PR model. PR is precision recall curve. Okay. That is one thing. You can also build the feature importance plot, which we have seen earlier, right? When we were building the normal models, our ML models. So pay 1 to 2 is the highest feature. Pay 3, 2 is second. Like that, it is giving all the feature importance. 24 features are there, right? 24 columns are there. Out of it, it has given which are the important ones. Next, you can also build confusion matrix. You just have to give plot model, that is the function, and you are passing which model it has to plot and which output. Now you want confusion matrix. So you're just saying plot is equal to confusion matrix. Okay, like that you can build the plots. Okay, so till now what we have done? We have done data pre-processing. We were able to compare models, right? And we are able to plot the models. Okay.
Ma'am, sorry to interrupt you.
Yes, again.
Ma'am,
Yeah.
For identifying the feature importance, does it has used PC or something else?
What is that?
Ma'am, actually it is showing the feature importance. So on what basis it has found the
random forest? Remember the concept of random forest.
Oh,
In random forest, we have given the model, right? Random forest has the capacity to give the feature importance.
Okay.
We have done this in class, if you remember.
Yeah.
Right?
Yeah, ma'am.
Yeah. Oh, you thought it is according to PCA? No. This is random forest.
Yes, ma'am.
Okay.
Thank you.
Next, you can evaluate model. Just simply say evaluate model tuned RF. Okay. Then next you are going to predict your model. So here we are not passing data like how we pass the data in our previous machine learning algorithms. When I say predict, it already knows that it has to use the test data. Okay, you just have to mention the model name and it will predict and give the output like this. What is the accuracy? What is the AUC? All that. Now the AUC was 0.74 for our model when we fit on the trained data. For test also it is giving the same. Okay. Now we have seen all the models, everything is done. You want a finalized model. In finalized model, the steps you are including are, this is like a pipeline, right? So setup is there, compare models is there, finalized model, whichever is giving the best accuracy, that will be the final model. So you're just saying finalized model, which is the model you want to finalize? Tuned RF. You can select any model which we have built. We can select a model and say final model. So it is stored in the final RF. When I say print, I get all the arguments which are giving me the best. This is like best parameters that we use in grid search. Okay. So once that is done, you're predicting your final model and getting all the things. This is on test data. Next, what you do is you want to predict on unseen data. Our validation data is there, right? So what you do is you go predict the model. What is the model? Final model. And here you are passing the data as unseen data. So it is building the model on that, it is predicting on that 5% data which we kept aside as validation. Okay, and this is the result, how it gives us for every record. When we have asked for head, right? So for every record, it is showing what is the prediction. Okay, so till now, we were able to build the model and predict the model. So everything is done. Next, what we have to do? We have to put it and save it as a pipeline. How are we going to do that? Simple. Again, 2 steps, right? from PyCaret. Oh, this check matrix is for accuracy. Okay, so this is for accuracy. What you're doing is you're getting the check matrix and you are passing the arguments. This is actual y, no, unseen predicted default. That means these are the predicted values for that, and label means the actual y. You are giving predicted y and actual y as your parameters. Matrix is accuracy. So we are getting 0.81 accuracy. With the tuned RF, when I use tuned RF, we are getting this. Now to save model, there is just one line. Save model, final RF. Final RF is our model, right? All the steps are stored here. And you are telling, giving a new name, RF, final RF model, whatever name you want to give, you can give. So this is the pipeline. Okay, now I think the doubt that you all had, how is it different from our ML algorithms, here it will be cleared. So it is getting the pipeline, okay, and it is doing imputer, it is storing the random forest, all the steps that were followed to reach our final model, all those are there in this model, final RF model, whatever the name we gave. Okay, when you save it, all the pipeline is safe. Next, whenever you want to reuse the model, we have built all these steps and we saved it. So whenever you get a new data, if you want to rerun the model, what you have to do? Load the saved model. Load underscore model. You're giving the name of the model, whatever you saved it with, and it will be loaded, right? Once it is loaded, what you do is you predict the model and you will give this name with which you have loaded, and then you will pass the data, new data points. You will get the predictions like this. Okay, we are able to reuse in the pipeline. All this is fine. But now I want to deploy it. Where to deploy? You deploy it on the cloud, right? So there's just one line of code for deploying. For other packages, we are using 3 or 4 lines, right, of code. Here, single line of code. This is the code that you will use. Okay. So now I think after looking at the code, it is very clear when I say this part, right? Automating the entire ML process. When I said, now it makes sense, end to end, from taking the data, right? You just passed in the data and just one command, only one word commands, and you are able to build the entire pipeline and then deploy it even in a single command or single line code. That is why we are saying it is low code library. Okay. So let me come to the meeting.
Can we use it for unsupervised learning also?
No.
Means
it is
only for
classification and regression. Or else just what you can do is go to the algorithms. 18 algorithms are there, right?
Yeah, yes, ma'am.
Just go through the list. You will understand it.
Yeah, okay.
Let me share the file before I forget. Okay. I'm just...
Ma'am, is it for only classification or regression time series?
Regression as well.
Okay, ma'am.
18 algorithms are there.
Okay, okay. Now, ma'am.
I think I can't share it here. I will ask the team to keep it in the description box, guys, the code.
Ma'am, ethically, is it good to work on this library, or should we follow our traditional approach?
Here, if you see, it is building all the models, right? So yes, you can see, depends again on the client. If he is not giving you much time and you have to build all the models, what will you do?
Yeah, yeah,
Can
yeah,
you
yeah.
see the use of it now?
Yes, ma'am.
Are you understanding?
Yeah, yeah, everything. Thank you, ma'am.
Right.
Really, it was
So
nice.
I'm not able to
Ma'am,
share the screen.
you can share the drive link also. We can go there and download it.
Yeah. So yeah, I'll do one thing. I'll keep it in the description. Now this will be there in YouTube, right? I will keep it in the description. You can just get it from there.
Okay, ma'am.
Thank you, everyone.
Yeah. Hello.
Yes.
Yeah, ma'am. One more question. Like in the real time projects when we are working, so like we have to do like in feature selection we have to like check like whether this feature is useful for us or not. But so we cannot rely on that part on the automation part, right? Because
That's
we
what
don't know that.
I'm telling. That is what I'm telling you.
Okay.
Sometimes the client is in really, he really wants it quick.
Okay.
So you don't have all that time. When you
Okay.
have time, yes, depends upon the client requirement and the time that is giving you.
Or else what we can do is like we can run it
Huh.
with the help of PyCaret and check what results it is
Hybrid,
giving,
yes,
and
yes,
according to
Malan, you
that we
can do
can do
that.
it.
You can
Yeah,
just
yeah.
go for hybrid wherever it
Okay.
is required. You can use these things.
Yeah.
Whatever you want to skip, like you can skip setup and do it
Mhm.
on your own.
Okay, then we
Yeah.
can compare our approach and machine's approach, like
Yes,
automatic
yes, you
automation
can do
approach.
that. When you have
Okay,
enough time on your hand, you can do all that.
sure. Okay, thank you.
Yes. Okay.
Ma'am, will you upload it on YouTube?
Yes, I have recorded it, right? Directly it will
Yeah.
be on the YouTube. It is available. What I will do is I will share it, the code in the description so that others also can use it. Who are
Okay, ma'am.
not in the webinar, they also will be able to access. So I'll keep it in the description. Okay.
Yeah, thank you, ma'am. Thank you.
Thank you, everyone.